attendees are in listen-only mode.
Hello, this is Sue Watkins. We will start the webinar in just a minute. Okay, we're going to get started. This is Sue Watkins, the Climate Change Program Manager with the Institute for Tribal Environmental Professionals at Northern Arizona University. Thank you for joining the webinar. This webinar series is highlighting tribes and tribal organizations that have been addressing climate change impacts through doing assessments and developing adaptation strategies. And it also provides an overview of funding and technical resources that are available both regionally and nationally. We are offering the webinars with support from the U.S. Forest Service Pacific Northwest Research Station. And in collaboration with them, the Pacific Northwest Tribal Climate Change Project at the University of Oregon and the North Pacific Landscape Conservation Cooperative. And I'm trying, okay. So today's webinar is focusing on work by the Nooksack Indian tribe. The next two webinars will be featuring case study presentations, and the last webinar on February 25th will feature a webinar on funding and technical resources for tribes, both regional and some national level resources. This webinar is being recorded, and we plan to post the presentation and webinar recording on ITEP's Climate Change Webinars webpage at the link shown on the screen. If you have any questions, please type them into the question box on the right side of your screen. And at the end of the presentation, the presenter will answer questions. You are muted, so any communications, please use the question box or the chat box. Following the webinar, you'll receive a link to a short online evaluation form. Please take a few minutes to provide feedback and suggestions of topics for future webinars. Here is the contact information for me and Christina Gonzalez-Maddox here at ITEP, who is working with me on these webinars. ITEP's Climate Change Program offers climate change trainings, webinars, Tribal Climate Change newsletter, and the Tribes and Climate Change website. We encourage you all to visit our program website at the URL on this webpage or on this slide. And please feel free to contact us if you have any questions about ITEP. We are very pleased to have Oliver Graw with us for this webinar. I'm going to switch the screen to his screen. Okay. All right. And Hopefully that will come up. Christina, I don't know if his screen is visible now.
Yeah, so Oliver, if you can just go ahead and click accept for the offer to show your screen.
Okay, while that's happening, I will introduce Oliver. Oliver Grau is currently the Water Resources Program Manager for the Nooksack Indian Tribe, where he manages the tribe's water quality and quantity investigations. He holds a BS in botany, a minor in geology, and an MS in watershed science. Oliver spent the first 25 years of his professional career as a private environmental consultant, dabbling in the fields of surface water hydrology, soils, vegetation, forestry, wetlands, physical habitat, reclamation science, and an environmental review for a variety of projects from the Sonoran Desert to alpine zone of Wyoming and Montana to the shorelines of the Salish Sea. In 2005, Oliver gave the public sector a try and served as a senior planner and natural resources manager for Whatcom County Planning and Development Services, after which he served as director of habitat restoration for the Institute for Applied Ecology in Corvallis. He has served in his current position with the Nooksack Indian Tribe for 3.5 years and has focused on climate change impacts on the glaciers and hydrology of the Nooksack River watershed. He is finally able to enjoy working with complete watersheds and in the field of glaciers, which is a lifelong dream come true. And with that, I'm going to let Oliver take it from here.
Great. Thank you, Sue. Appreciate this opportunity to present on the Nooksack Indian Tribe climate change studies. The objectives of this presentation include describing the components of our climate change project, discuss how the information will be used by the tribe to address climate change, include some case studies that the project has addressed in regard to climate change, and introduce the Nooksack Indian Tribe. Funding sources for our overall climate change project have come from a variety of grantors, including the EPA for our Performance Partnership Grant, funding under the National the National Estuaries Program for our Capacity Building Grant, Competitive Clean Water Act 319 grant from the Bureau of Indian Affairs, the Northwest Indian Fisheries Commission, and the North Pacific Landscape Conservation Cooperative, and we appreciate the funding from all these grantors. Excuse me. Some of the background on the Nooksack Indian Tribe. The tribe was recognized under the Treaty of Point Elliott of 1855. The tribe is located near Deming, Washington, and it's about 15 miles east of Bellingham, Washington, at the foot of the Cascade Mountains. The reservation is only about 2.2 acres in size, which obviously is not very large, but there's about 1,000 acres of trust land. Nooksack translated means mountain men and or fern people. It's a small tribe consisting of about 2,000 members. Under the Treaty of Point Elliott, the tribe may have given up some rights to land, but not to resources within their UNA area. And UNA area refers to the usual and accustomed grounds and stations area, and that area is much larger than the reservation itself or the trust lands. And I'll talk more about that here momentarily. The UNA area extends throughout the Nooksack and Samish watersheds. From the international border south to Padilla Bay, it encompasses about 720,000 acres of freshwater watersheds and about 428 miles of marine shoreline. And again, that includes the islands of northern Puget Sound. In other words, obviously it occurs in northern Puget Sound. So again, the tribe occurs in northwest Washington, and its UNA area extends north of the Canadian border and south to Padilla Bay. The tribe's focus on the Nooksack River, which flows in, and it is comprised of a main stem and 3 forks, including the South Fork, Middle Fork, and North Fork Nooksack rivers. And again, I'll be talking about each of those forks of the Nooksack River. The watershed arises on the high mountains of the North Cascades, including the Sisters Range, the prominent Mount Baker, Mount Chuckson, and the other high peaks of the North Cascades, including the mountains within North Cascades National Park. The tribal headquarters is located right here in Deming, Washington. The tribe relies on harvestable surpluses of Pacific salmon for ceremonial, heritage, subsistence, and commercial uses. Salmon are currently and will continue to be stressed by legacy impacts from land uses. And again, I'll be talking a little bit more about legacy impacts henceforth. Climate change impacts will cumulatively add to legacy impacts of altered stream flows, temperature, and sediment. Huge efforts are being directed towards in-stream restoration to enhance salmon recovery, primarily in response to legacy impacts. And one of the points of my presentation is that in-stream restoration can't just address existing conditions. It needs to be modified to address climate change impacts in the future. Other watershed restoration actions will be necessary to ensure persistence and continued recovery of Pacific salmon that the tribe relies on. The tribe has initiated a climate change project aimed at evaluating the impacts of climate change on the hydrology of the Nooksack River and salmon survival. This information is needed to plan for effective habitat restoration measures that address the additional stresses of future climate change, and again, that's on top of or cumulatively with existing legacy impacts. One of the other issues is the abundance of salmon stocks in the Nooksack River. In the late 1800s, and this is based on catch records, there were about 70,000 returnees of coho salmon, 20,000 returnees of Chinook salmon, and about 50,000 returnees of steelhead. However, today, those numbers have dropped to about 280 Chinook salmon, about 4,500 coho salmon, and that's a huge reduction in salmon stocks today. So native salmon runs today are less than 8% of the runs in the late 1800s. And again, the Nooksack tribe relies on these salmon for various uses, as I've already indicated. The Nooksack Indian Tribe Climate Change Project, initiated as a small work plan component of our EPA Performance Partnership Grant, starting in fiscal year 2010. It was focused on a literature review on glacier ablation, that is, the loss of glacier mass due to melting, sublimation, and evaporation, and changes in snow accumulation. However, today, our climate change project is greatly expanded and is much more comprehensive, and it includes baseline stream temperature monitoring, climate change stream temperature modeling, and again, the temperature modeling for our climate change project is primarily was accomplished by Tetra Tech under contract with the EPA and the Washington Department of Ecology. It involves glacier ablation field studies and modeling. The field studies are being conducted by the Nooksack Indian Tribe in coordination with Dr. Maury Pelto, a professor of geology at Nichols College in Massachusetts, and he's been studying glacier behavior in the Northern Cascades now for 30 years, and he has quite a large database on glacier ablation. We've contracted with the University of Washington to do some initial glacier modeling, which will be part of hydrologic modeling that's being accomplished by Western Washington University, and that study will update the hydrology of the Nooksack River based on more robust climate downscaling, and then also run several climate change scenarios to show the change in river flows with climate change under several scenarios. We're also, as indicated, evaluating stream temperature, mostly establishing baseline as a reference to determine or discern climate change impacts on stream temperature. We're measuring tributary discharge to the river, including low flow studies in consultation with the Northwest Indian Fisheries Commission. We're evaluating sediment dynamics to changed hydrology in the river basin, and we're also involved with groundwater modeling, and we recently contracted with the USGS to do a special groundwater study on the South Fork Nooksack River, which looked at the influence of groundwater on cold water refugia within the South Fork Nooksack River. And the USGS has recently completed their report on that study, and if anybody's interested, send me an email and I can send you the link for that study. The project also involves climate change impact analysis based on the information I just mentioned. It involves a vulnerability assessment for salmon, and obviously adaptation planning, which includes evaluating salmon habitat restoration effectiveness evaluation and planning for climate change. At this point in time, the current project will not address sea level rise, marine impacts, shoreline, upland resources. One of the objectives of our overall climate change project is to address water resource management issues and salmon recovery issues in the Nooksack watershed of interest to all stakeholders. And so we're conducting this project to contribute to public domain, and so other stakeholders within the watershed can use this information to plan for climate change within their own scope of concern. I've mentioned legacy impacts several times so far, and we'll talk about them off and on through this presentation. I thought I'd take a moment to describe what legacy impacts are exactly. Legacy impacts are adverse impacts on the natural systems that exist today but caused by past land management. And the planning for climate change must involve addressing the cumulative impact of both legacy impacts and climate change impacts. The point is that depending on the system and location and the circumstance, legacy impacts are likely to be of greater magnitude than climate change impacts. However, climate change impacts may be minor, they still could be so-called the straw that breaks the camel's back. And so it's important to cumulatively address both legacy impacts and climate impacts in a climate change project. And what have caused legacy impacts within the Nooksack River? Well, intensive and extensive timber harvest has altered the hydrology of the river basin. Unstable forest roads, which have caused landslides, which have caused channel blockages and subsequent debris flows, delivering large amounts of sediment to the river. Again, caused landslides and debris flows, also clogging channels. Loss of stream buffers, which has caused increased heat loading to tributaries and the mainstem rivers. Agriculture, causing the loss of shading and exposed ground. Transportation infrastructure, including highways and railroads. Development, including impervious surfaces. Flood control, which has involved constricting channels and separating the river from its floodplain. Again, forest practices have been the largest contributor to legacy impacts, mostly in the form of clear cuts, which have resulted in debris flows causing excessive sediment loading to the rivers. That's all part of the existing level of impact caused by past land management. And so it also involves the loss of riparian buffering. So as an example, this is a perennial non-fish bearing stream, and oftentimes buffering is not required on these sensitive streams, as shown in this slide. And obviously there's, even though it may not be fish bearing, obviously there's a heat loading impact on stream temperature. And so these are all examples of legacy impacts, including failures of road embankments. And all of this means an excess of sediment in the rivers, causing channel aggradation, i.e. the deposition of sediment, causing the channels to be shallower over a wider area and more susceptible to heat loading. So obviously all these legacy impacts have a huge adverse impacts on fish. Okay, our project is designed to not just address climate change impacts, but also addresses Clean Water Act compliance, endangered species recovery, climate change, treaty resources, and legacy impacts in one comprehensive holistic project. Let's take a look at now some of the projected climate change impacts in our region. Generally, there could be an increasing air temperature of 3 to 4 degrees C, changes in annual and seasonal precipitation and types of precipitation. Generally, there could be as much of a 10% decrease in precipitation, increased frequency of rain on snow events, declining snowpacks of about 40%, including the depth of snowpack and the area of snowpack. Most glaciers in the North Cascades Mountains will disappear. There'll be altered hydrographs, including a reduction of about 40% of flow in the summer, but perhaps an increase of 30% in the winter. There'll be a narrower hydrograph base and higher peak flows causing floods. And this is some modeling work conducted by the Climate Impacts Group at the University of Washington, showing the projected effects of climate change on the hydrology of the river. And the blue line shows the current hydrograph, annual hydrograph for the Nooksack River, and the red line shows the projected flow caused by climate change over various scenarios in 2020, 2040s, and 2080s. You can see the shape of the hydrograph changes, higher peaks during the winter time, but probably more important for salmon is the reduction in base flow in the summer, and so the base flow declines earlier in the summer and the flows are less, and that's a critical time for salmon survival. This graph over here shows a huge reduction in snow water equivalent associated with the snowpack, and again the current snowpack or snow water equivalent is shown in the blue and the reduction is shown in red, and so that just indicates the magnitude of projected climate change in the Nooksack River Basin. There'll be a change in sediment loading and transport dynamics, likely an increase in sediment loading. Increased summer water temperatures of 2 to 3 degrees centigrade. And again, that's somewhat consistent with the work recently conducted by Dr. Dan Isaac of the U.S. Forest Service in his statistical modeling of stream temperature in the face of climate change. This is some modeling recently done by Tetra Tech for a project we're associated with, and they actually show for the South Fork Nooksack River, which is the river that's suffered the most from legacy impacts, of potentially a 7-degree increase from current conditions. And that's a huge potential increase projected by the A1B climate change scenario. Be decreasing spring water temperatures, and again that's likely caused by earlier snowmelt during the year, including early spring. On top of the legacy impacts, there will be likely a greater magnitude. As I indicated, legacy impacts are probably of greater magnitude than climate change impacts. However, climate change impacts, perhaps minor, could be the straw that breaks the camel's back. What do we mean by altered hydrology again? Well, glacier ablation, i.e. the loss of glacial mass, which essentially function as reservoirs for water supply late in the summer. Altered snow accumulation and melt, altered hydrographs, altered precipitation dynamics, altered sediment dynamics, It also involves changes in water availability for municipal uses, commercial uses, industrial uses, agriculture, fish. Involves shifts and changes in flood frequency and magnitude, involves changes in sediment dynamics, and that includes altered landslide frequency and magnitude associated with glacial recession. It includes modifications or changes in sediment load and transport down the Nooksack River. It involves altered channel morphology and bed materials. It also could include infrastructure damage, and what I mean by that is the sediment loading to the Nooksack River causes an increase in suspended sediment, which adversely affects the withdrawal of water from the Nooksack River for various municipalities, including the cities of Linden, Ferndale, and Public Utility District Number 1. It involves adverse effects to fish habitat and survival, including altered hydrology in terms of peak flows, flood flows, and low flows. Changes in water temperatures, obviously increase in summer, increase in fall, increase in winter, but perhaps a decrease of temperatures in early spring. Altered bed materials in terms of the size of the bed materials, but also clogging of the interstitial spaces in the alluvium of the bed material. Reduced habitat availability and quality to fish. After we assess the impacts of climate change on the systems, then we take that information and apply it to a specific resource, and in this case, it's salmon. And we evaluate the impacts of climate change on salmon in terms of altered flow regimes, the warmer stream temperatures during critical times in the life cycle of the salmon, an increase in the sedimentation of the river and the stream beds, again having adverse effects on salmon. The sedimentation is likely to reduce the amount of gravel substrate available for spawning. It involves reduced available habitat. It includes temperature-related physiological stress and pathologies due to climate change, reduce reproductive success, shift in species composition, outmigration of native species and in-migration of other native species, invasion of non-native fish, impacts on existing recovery actions and habitat restoration plans, and in terms of all 9 species of Pacific salmon, climate change will affect all life stages of this salmon. After we do the vulnerability assessment of climate change impacts to our resource of interest, salmon, then we implement adaptation planning. And adaptation planning must include the rate of watershed recovery from legacy impacts. Again, that's a dynamic temporal response of the watershed to legacy impacts. Obviously, climate change is also a temporal response over time, and so you need to integrate the rates of recovery from legacy impacts with the rates of climate change in adaptation planning. Obviously, involves adaptive management, i.e., shifting or adapting or adopting new restoration strategies that better address climate change. Involves reprioritizing restoration actions as laid out in the 10-year salmon recovery plan for the Nooksack River Basin. So what does this mean for salmon recovery and habitat restoration? Well, an effective assessment of hydrology of the system is necessary to plan for salmon habitat restoration in the face of climate change. Climate change will result in changes to that hydrology. An effective restoration program needs to be modified in order to address the altered hydrology. In combination with engineered log jams, the most effective restoration actions include the following. Now, the reason I mention engineered log jams is, as I'll talk about here momentarily, is that engineered log jam is the primary restoration tool that various organizations, including the Nooksack Indian Tribe, use to restore habitat and to enhance salmon recovery in the Nooksack River. But that's not the only restoration tool that should be applied in response to climate change. And these other restoration actions include reconnecting the river with its floodplain, relocation of flood control berms, dikes, and transportation structures, vertical reconnection of the river, including reestablishing important hyporheic flow and groundwater input, primarily cold water relative to the temperature of the stream itself, wetlands restoration, and riparian planting. Most of these effective measures need to address altered hydrology due to climate change to be effective in the future, and that's why so much effort is being put into establishing what are the existing baseline conditions of the Nooksack River watershed and how flow will change with climate change. So I've talked about our studies on glaciers. So where are the glaciers in the Nooksack River Basin? Well, first of all, again, the Nooksack River Basin includes Three Forks, South Fork, Middle Fork, North Fork Nooksack River, and most of the glaciers occur on Mount Baker, which is in the watershed of the North Fork and the Middle Fork primarily. And this is Mount Baker. You can see the area of glacier mass. The other major area in the Nooksack River Basin is Mount Shuckson, and then there's scattered other smaller glaciers on the higher peaks of the North Cascades in the Nooksack River Basin. And there's also some minor glaciers on the Sisters Range, which drain into the Middle Fork, and then smaller vestigial ice or glacierettes in the South Fork watershed. And again, this just shows in more detail the glacier area in the North Fork, in the Middle Fork, and the South Fork. And in regard to the Three Forks, the North Fork has the most glacial area of about 24 square kilometers. The Middle Fork, about 7 square kilometers, and the South Fork only about 0.1 kilometers. And the reason it's important to highlight this is that as glaciers continue to ablate with climate change, there'll be some immediate effects on the South Fork. That ice will disappear very shortly. The Middle Fork and the North Fork, most of the glaciers in the lower elevations will disappear, with glaciers at the higher elevation on Mount Baker perhaps persisting into the future with climate change. As indicated, we're implementing field studies on glaciers in the North Cascades in the Nooksack River Basin, and it involves first locating glaciers that are accessible and aren't too dangerous in terms of risk to study. And it involves getting up onto the glacier and measuring the depth of the snowpack of this year's snowfall on top of either last year's accumulated snow that's left over and or on top of the glacial ice of the glacier itself. We put in ablation stakes to measure the rate of snowmelt, and we also measure the depth of snowpack and the layering of snowpack year to year to year in crevices on the glaciers. And again, this is Dr. Maury Pelto with his 2 assistants, which are his children. We look at the area of exposed ice throughout the season. And as an example, this is the Shoals Glacier, one of our study glaciers, and this is taken at the beginning of the melt season, early August, and by mid-August you can see there's quite a bit of exposed ice. And so what we're doing is trying to measure the rate of snowmelt, and by doing that you can keep track of the firn line, determine whether, based on mass balance, whether the glacier is advancing or increasing in size and volume or decreasing in size and volume. And that's important to measure that year to year to year to get a picture of the behavior of the glacier in response to the climate change that has already occurred, and gives us some information so we can predict how glaciers will behave into the future with additional climate change. And ablation or snowmelt can be quite substantive on some of these lower elevation glaciers, such as the Shoals Glacier. And just in the 3 years that we've been studying this glacier with Dr. Moripalto, there's been substantive recession of this glacier and a changed mass balance, suggesting that this glacier is quickly ablating. We also use remote sensing in terms of Landsat remote sensing to also map out the loss of snowpack on top of a glacier. Again, this is work being done by Dr. Moripalto, and this is the Shoals Glacier on October 4th, and then by September 12th you can see the large area of exposed ice. And this, again, if this continues year to year to year, that would suggest that this glacier is in disequilibrium and is adjusting to new climate conditions and is ablating and losing aerial extent and volume. We're measuring the outflow from these glaciers. We're putting in level loggers to keep track of stream stage, measuring velocity and cross-sectional area several times during the snowmelt season, so we can develop a stage discharge rating curve for these outflow streams. It's interesting to note that this picture is taken at the beginning of the snowmelt season. Later on, mid to late August, the sediment load in the stream has greatly increased, and this additional sediment is coming from the exposed surface of the glacier that has accumulated fine sediment. We're measuring sediment load and turbidity on all of these outflow streams from these glaciers, and we're trying to discriminate between various types of streams and its sediment load. So as an example, here's the confluence of two different streams. This is Wells Creek, this is Dodd Creek. Dodd Creek emanates from a valley glacier, the Mazama Glacier, which provides huge amounts of sediment to the stream, where the clear stream, Wells Creek, is primarily drains from a snowmelt-dominated watershed. And so you can see the difference between a heavily glaciated watershed and a snowmelt watershed, the difference in sediment load. And that sediment loading has come from these steep, unconsolidated, thin glacial moraine veneer on these steep side slopes that slough as the glacier recedes, and as the glacier recedes, it unloads the toe of these slopes, unloading the slopes and causing mass failures. So some of our recent observations and findings from our studies: in terms of glaciers, there's been substantial recession on all glaciers from the conclusion of the Little Ice Age in about 1890, the year 1890, and that's the most recent maximum glacial extent. And as you may recall from climate change has been identified starting in the late 1890s due to fossil fuels burning, and so that's one of the likely causes of the glacier recession. There's been about 1,000 to 1,600 feet of recession of these valley glaciers just since about 1979, and about 600 to 800 feet of recession on hanging glaciers. There's been a steady decline in glacier mass balance, 10% reduction in glacier area since 1984. And again, a lot of these statistics is coming from Dr. Moripalto. These trends will likely continue with climate change, and most low to mid-elevation glaciers will likely disappear. In terms of flow, glacier melt has a minor diurnal fluctuation of flow. Snow has greater diurnal fluctuation of flow. There's been about a 26% decrease in summer flows in the Nooksack River since about 1963. River temperatures have risen about 0.9 degrees centigrade since the 1900s. Glacier melt is very important for late summer flows and for temperature modulation, and so if there's changes in glacier melt or disappearance of glaciers due to climate change, that'll have huge impacts on the ability of salmon to survive with climate change. be 50 to 60% of the North Fork Nooksack River in August comes from snowmelt. And so again, glacier melt is a huge contributor to flow in the Nooksack River in late August, which is a critical time for salmon survival. And again, the North Fork and the Middle Fork watersheds, which have the largest amount of glacial area with climate change, will be very similar to the conditions in the South Fork. In the South Fork, Nooksack River has suffered larger impacts due to legacy impacts. The watershed is of lower elevation, and climate change will have the greatest early impact on the South Fork. And the idea being is that with climate change, the North Fork, Middle Fork being supplied by glacier melt will transition to being more similar to the South Fork Nooksack River. In terms of sediment, valley glaciers have already delivered most of the sediment since the end of the Little Ice Age in 1890. Mass wasting of oversteepened glacial valleys, still producing substantial sediment input today. Most residual glaciers produce moderate amounts of suspended sediment from the surface of the glacier and in the interior of the glacier. Snowmelt-fed streams carry minor amounts of suspended sediment. And in terms of what we're finding, again, is quite a bit of glacier recession. This shows the Mazama Glacier, which is a valley glacier on the north side of Mount Baker, and you can see by this series of photos the rate at which the glacier is receded. You can see the margins here over the past few years, and again the relationship to the very steep slopes that form the valley sides of these valley glaciers. A very simple analysis can be accomplished using Google Earth to evaluate recession. So this is the Roosevelt Glacier on the north side of Mount Baker, and it's receded from approximately this location in 1890 up to this location in 2013, and that's about an 8,000 foot recession. In terms of the hanging glaciers or the glacierettes, this is the Heliotrope Glacier, and it's receded about 3,400 feet since 1890 from this position to this position. So just since the end of the Little Ice Age, there's been huge glacier recession and loss in volume, which obviously affects the flow in the rivers, and that's why since I think 1979 there's been a substantial reduction in flow in the Nooksack River during the summer. In terms of our glacier recession, for all the glaciers that flow into the Nooksack River, there's been an average recession of about 6,600 feet since the end of the Little Ice Age. The other implication of glacier recession, I've mentioned this before, are the unloading of steep unconsolidated slopes of these valley glaciers. And as an example, you can see a recent mass failure at the toe of the Deming Glacier that occurred on May 30th of 2013, and that resulted in a debris torrent coming down the Middle Fork of the Nooksack River. And you can see the excessive sediment that's been carried down the river and the adverse modification of the channel bed itself. And so these types of events, due to recession of the glaciers, will become more frequent and of greater magnitude with climate change. So what is the relevance and application of this scientific information? Well, we use this information to identify impacts of climate change on water users in the watershed. And as I've mentioned before, that includes municipal, industrial, residential, agriculture, flood control, and fish. We are primarily concerned about fish in terms of salmon recovery, and that's not just endangered species recovery, it's also trying to promote salmon in sufficient numbers for harvest for the tribe, because they rely on the salmon for various uses, as I indicated previously. Involves sustainable harvestable quantities, treaty resources, and again that's a major focus of our climate change project, is what are the impacts of climate change on treaty resources. Also, it has great relevance to our restoration planning program. Now, as I indicated at the very beginning of this webinar, we have a couple case studies that we've been involved with that addresses climate change. And one of these projects is a temperature total maximum daily load project and a pilot climate change project on the South Fork Nooksack River. South Fork Nooksack River is highly temperature impaired. It's a Category 5 impaired water on the Clean Water Act 303D list, and what that means, that's a highly impaired water body, and if it's Category 5, the Clean Water Act requires that a total maximum daily load analysis be conducted for that water, and that involves identifying what natural conditions are prior to the impacts of land management. It involves identifying what all of the existing pollution sources to the river are, and then allocates those contributions of water quality impairment in the watershed to determine whether the water body has the capacity to accommodate future additional water quality impairments. It looks at the benefit, it considers the beneficial use of the water in regard to salmon. So salmon survival and habitat is the beneficial use identified by the Clean Water Act and the standards for the South Fork Nooksack River. The TMDL project was initiated by Washington Department of Ecology and EPA in 2011. The Nooksack Indian Tribe and the Lummi Nation provided early technical input to the TMDL planning process. The tribes were concerned that the temperature TMDL would not directly assess upland watershed processes, legacy impacts, and climate change, and or include reasonable assessment of natural conditions. And we felt that the TMDL really needed to address these concerns to be an effective tool for trying to improve the water quality in the Nooksack River, based on existing conditions, but also taking climate change into consideration. So if the point of the TMDL was to bring the South Fork River into water quality compliance, how would the TMDL address salmon fish survival, the beneficial use of the river under the Clean Water Act? Well, of particular concern is how natural conditions were defined in the TMDL. And the criteria used for the water quality impairment in the Nooksack River, South Fork Nooksack River, primarily temperature, is based on, again, beneficial use, i.e. salmon habitat and survival, but it addresses the species of salmon, the life stage of the salmon, the season of use, and the location. So some of the implications of natural condition analysis in a TMDL is that the outcome of the TMDL is highly dependent on the assumptions made for the modeled natural conditions or system potential. And these are the conditions that were present prior to the pollution problem. That's how it's defined in the Clean Water Act. In other words, natural conditions or the climax conditions. The TMDL assumptions for the South Fork Nooksack River really weren't consistent with the tribe's understanding of natural conditions, and through our involvement in the temperature TMDL, we were able to have the project include our perception of natural conditions. And so the project used data from the tribe, and the issue of natural conditions is very important to the outcome of the TMDL project, because there's a section of the Washington Administrative Code that can be variously applied to a TMDL. And this section of the code states that if the modeled natural conditions of a Category 5 water do not meet the applicable standards, then the new standard is that modeled temperature regime. And in other words, a possible interpretation of this is that there is no temperature issue in the South Fork and the Nooksack River. And we all recognize that that's just not true. This has huge implications on salmon recovery and restoration. And so our involvement on this temperature TMDL was that through the information we provided the project, the natural condition, the modeled natural conditions were reduced from the original prediction, say for the whole river, from about 18.7 degrees Celsius down to 15.8 degrees Celsius, which is very close to the water quality criteria of 16. And so we feel that the results of the TMDL that included or addressed natural conditions was unreasonable, and we feel that our perception of natural conditions is much more appropriate in this TMDL process. Let's go back and take a look at climate change. What happens with stream temperature with confounding effects of projected climate change? Does it get worse? Well, obviously it does. How should habitat restoration adapt to climate change? The potential answers to these questions are addressed by a pilot research project that's being conducted by the EPA Office of Research and Development, as led by Steve Klein. I'll talk more about that here henceforth. This project is currently being implemented with the TMDL project, and EPA was developing a pilot research project that integrated climate change into a temperature TMDL. EPA decided to apply the pilot research project to the South Fork Nooksack River. The pilot research project is designed to support the TMDL project in reducing the impact of high temperatures on salmon, also taking climate change into consideration. So more importantly, this pilot project supports both salmon recovery and Clean Water Act compliance by focusing on what salmon habitat restoration actions would be needed to promote salmon survival in the face of climate change at population levels that provide for harvestable surpluses. So as indicated, this climate change pilot research project is being led by Steve Klein of Office of Research and Development, Corvallis. EPA retained Tetra Tech to facilitate the project and conduct the quantitative modeling. And as indicated previously, this project relies heavily on the local technical input provided by the Nooksack Indian tribe. The pilot research project is divided into two different components. One is the quantitative assessment that involves empirical modeling of stream temperature, including riparian shading, with and without climate change for various climate change scenarios at time horizons of the 2020s, 2040s, and 2080s. The pilot research project is responsive to the Clean Water Act numeric cold water temperature standards. And then the other component is the qualitative assessment, and that's the part of the pilot project that the Nooksack Indian tribe is heavily involved with. And the qualitative assessment involves a comprehensive analysis of freshwater habitat for salmon restoration in the river under climate change. It will result in a prioritized list of climate change adaptation strategies that support salmon restoration in the river under climate change scenarios. Together, these assessments represent a robust and comprehensive action to get to the intent of the water quality standards, protect the water quality beneficial uses, and facilitate meeting endangered species recovery and harvestable quantities of salmon under climate change scenarios. The process of implementing the qualitative assessment involves characterizing existing conditions in the South Fork, assessing impacts of climate change on species, life form, and location. And again, this graphic shows for Chinook salmon for various times of the year under various types of impacts. Again, the blue being increased winter peak flows, the yellow loss of spring snowmelt, pink being increased summer temperatures, and the bars representing the various life stages of spring Chinook. You can see that spring Chinook will be impacted by climate change all times of the years at all life stages. And so climate change impacts will definitely have an impact on the survival of spring Chinook and how restoration planning is accomplished in the Nooksack River to accommodate climate change. Also, it involves reviewing existing fish habitat restoration tools and plans, and that primarily involves the restoration actions identified in the Salmon Recovery Plan, which was prepared for the Nooksack River Basin. It involves reprioritizing strategies based on tools that are most robust in the face of climate change. And really, the centerpiece of the qualitative assessment involves applying the methods of Beachy et al. To review and reprioritize restoration actions. It also involves conducting workshops to inform agencies and stakeholder groups, review existing information related to watershed condition, riparian shading, channel characteristics. It involves soliciting feedback from knowledgeable technical staff. And again, as I indicated, the centerpiece is applying Beachy et al.'s document, Restoring Salmon Habitat for a Changing Climate. And it involves asking 4 foundation questions in regard to restoration planning. What habitat factors limit salmon recovery? What are the local predicted climate change effects? Do proposed restoration actions reduce climate change effects? Do proposed restoration actions increase habitat diversity or ecosystem resilience? And this graphic shows a matrix that's conceptual. It's not specific to the Nooksack River, but what it shows is the relationship of restoration actions and the type of climate change impact. And you can see here that given a climate change impact, the restoration tools have variable effectiveness in the face of climate change, including longitudinal connectivity, floodplain connectivity, restoration of incised channel, restoration of stream flow, restoration of riparian function, reduction in sediment supply, and construction of in-stream habitat. So per Beachy, the primary restoration strategies that should be applied in the face of climate change include longitudinal connectivity, floodplain connectivity, restoration of incised channels, revegetating buffer of all streams, not just the main stem of the river, but all tributary channels. And all this in addition to our current in-stream restoration program, which primarily focuses on engineered log jams. And so we have a series of log jams in the South Fork of Nooksack River located at these positions. And there's about 100 of these individual log jam structures that have been installed within South Fork River. Main functions is to create scour pools which provide cold water refugia to fish during times of excessive stream temperatures and low flows in late August. To date, there's been about 100 log jams in the river at a total cost of about $7 million. These log jams create cold water temperature refuges that help fish hold and survive until water temperatures decrease and stream flows increase. Log jams are not as effective as other measures identified previously in the face of climate change. They provide fish with a bridge to respond to climate change. So in conclusion of this presentation, okay, under the total maximum daily load project, there's a possibility that the standards will change in a manner that does not protect fish in regard to the beneficial use under the Water Act. The pilot research project implemented that addresses climate change quantitatively and qualitatively. Quantitative analysis concludes that stream temperatures will get worse for fish in the face of climate change. According to Beachy, the type of restoration makes a difference in response to climate change. The most effective actions take significant time and coordination with various stakeholders, including time for trees to provide effective shade, time to remove levees, setback levees to reconnect floodplains, the time it takes to manage sediment loads from the watershed, and also address continuing existing legacy impacts. It's very important to get started with planning and implementing restoration now so that benefits will be in place prior to or when climate change impacts become more severe. And I think one of the more important take-homes of this presentation is that as a tribe, we engaged the regulatory process, engaged climate change impacts analysis, vulnerability assessment, and adaptation planning, and had a major influence on how these various processes were implemented. And so we believe we've had very positive influence on how these various programs have occurred. And that's the end of the presentation. I appreciate your attention and interest, and I'd be happy to answer any questions that are identified. Thank you.
Great. Thank you so much, Oliver. That was really interesting. A lot of really fantastic slides, a lot of great information. We have a questions box where people can type in questions. So if you have a question for Oliver, please type it in there. There is one question that was typed in pretty early on in the presentation. Does the study also involve assessing anthropogenic limiting factors on salmon production?
Well, yes, and I think that gets at the whole notion of evaluating what legacy impacts have been. So the point is that legacy impacts are essentially forms of anthropogenic limiting factors.
Okay, thank you. Somebody else typed in a comment, basically saying, thank you for, the interesting presentation, and saying that they just hadn't really grasped what the effects of glacial melt were until now. So it was a comment of appreciation. And we're waiting for more questions, so please type them in. I do have a question myself. It sounds like a lot of your work has involved partnerships with others outside of the tribe, and I wonder if you could speak a little bit about that and suggestions for establishing effective partnerships.
Okay, a very good question. And again, we've actively engaged a very large work group, including ITEP and the Pacific Northwest Tribal Climate Change Network. We've engaged the University of Washington to do glacier modeling. We've engaged Dr. Maury Pelto of Nichols College to work with us on field studies to measure snow melt and the rate of glacier ablation. We work very closely with and have contracted Western Washington University to do detailed hydrologic modeling within the watershed. And all of this work and the results of this work is being shared with what's called the Water Resource Inventory Area Number 1. And that entity includes all of the Nooksack River Basin, and it's a function of the state of Washington's Watershed Planning Act. And there are several partners involved with the WIRA-1 project, which has a watershed management component and a salmon recovery component, but includes such agencies as City of Bellingham, Whatcom County, Whatcom Public Utility District Number 1, Nooksack Indian Tribe, Lummi Nation, as well as the Washington Department of Fish and Wildlife. I think I already mentioned Department of Ecology, small cities within Whatcom County. And we're doing all this work in a manner that can be used to the benefit of these other entities, but also this work is being done as a pilot, and this work can serve as a template that can be used by other tribes and other similar watersheds, such as the Upper Skagit tribe, the Soxhawtl tribe, Swinomish tribe, and on down the west slope of the North Cascades. And so it's very important to to team with other organizations that have similar objectives in planning for climate change.
Okay, thank you, Oliver. And I see we actually have quite a few questions now. One is wanting your contact number and email, and if it's okay with you, Oliver, I will include that in an email I'm going to send out. I have an updated webinar announcement with more information about the next webinar, and I will include your email address so people can contact you.
Yes, that's fantastic. I'm happy to share experiences and answer questions over the phone or via email.
Okay. Here's a question. Will this climate change affect the efforts to get the watersheds back into its original fire regime?
Our work, no, is not addressing the fire regime, because on the west slope, although there will be an increase in the frequency, area, and magnitude of wildfire, it's not as big of a factor on watershed processes as, say, glacier ablation and increased temperatures and changed hydrographs. I'm not saying that fire won't have an impact on the river basin. I would predict that it's of less magnitude as some of these other factors. Also, a bigger factor in terms of watershed processes is the area of timber harvest, because the watershed is much more affected by existing ongoing forest harvest activities than what altered fire regimes would likely be in the face of climate change.
Okay, thank you. Here's another question, which is actually a question I had for you. She says, this was a great presentation, thank you. Just curious to see where, or excuse me, just curious where you see your tribe's climate change research and adaptation work moving towards in the future beyond these great projects.
Well, as I indicated, we're conducting this work as a pilot. And so the idea being is that it'll create a template that can be used by other organizations, including other tribes. Our current project looks at each fork of the Nooksack River with slightly different intensity. So right now, for instance, we're looking very intensively at the South Fork and the impacts of climate change on the South Fork and what must be done for restoration, primarily through EPA's climate change pilot research project. Once that's completed here in the next, say, year, we'll be taking that template and applying it to the Middle Fork and the North Fork Nooksack rivers. Similarly, that template could be used in other watersheds. In addition to that, we'll be continuing to look very carefully on the vulnerability assessment, not just for salmon, but for other natural resource uses within the watershed. So what I presented is just kind of a snapshot in time of what we've done to date and an indication of where we'll go in the future.
Okay, thank you. The next question, you mentioned relocation of dikes and transport structures. Can you describe what these transport structures are? Thanks.
Huge highway road prism embankments that encroach on the channel itself, railway embankments that encroach on the channel. And so it does several things. One, these structures remove riparian shading. They usually involve hard armoring of the river, and it reduces the ability of the river to access its floodplain except for very large flood events. And so the idea being is that per Tim Beachy's general guidance or procedures, one of the most effective measures that can be implemented in taking climate change into consideration is trying to move these structures back to give access to the floodplain by the river itself. And I indicated that there's huge political impediments to doing that, but as a community, if we're going to take addressing climate change and making our systems climate ready, we have to start now working with transportation departments, working with the railroad, working with flood control districts to try to move these structures back from the channel. That's a huge political process, but we need to get started now if it's going to be effective in the future for climate change.
Okay, the next, a comment and a question. Very good science, more work to do. How can TMDL policy / law be reactive to temperatures?
Well, again, as I indicated, temperature is a pollutant under the Clean Water Act, and the TMDL program addresses impairment of all water bodies regardless of the parameter of impairment. And so the TMDL commonly is applied to water bodies that are temperature impaired. And our hope with this project is that the TMDL process will include the effects of climate change, because what the TMDL does is the analysis leads to recommendations on how to further reduce impacts on water quality in the watershed. But those recommendations have to take climate change into consideration to be fully effective. And so that's what's unique about this project in terms of informing the TMDL project on how to be climate ready or address water quality issues in the context of climate change.
Okay, the next is just another comment. Great presentation, Oliver. We in Northwest Montana are seeing the same impacts to glaciers when we look at the reduction in glaciers in Glacier National Park. It is very much concerning. Thank you. Then a question, have you considered the method of communication for tribal communities? Oftentimes a top-down information approach can be perceived negatively. Has there been any consideration of outreach in a more face-to-face human approach?
Yes, we have given several presentations to various tribal work groups focused on climate change. And so we're actively sharing this information. I'm not saying this from a policy standpoint, but my technical perspective is that since all of our work is being funded by the public sector, it's a public domain. And so we will openly share the results of our climate change project. I'm not sure if that specifically addresses the question, but that's my answer.
Okay, we just have time for maybe one or two more questions. The next one I have here is, can you speak more about how the project incorporates understanding of human vulnerability, risks, impacts of livelihoods, and traditional use and culture, etc.?
Yes, that's one of our future steps. Right now, our program is primarily focused on fish and doing what's necessary to promote fish survival, fish that the Nooksack Indian tribe relies on for cultural, heritage, subsistence, and commercial uses. But that transforms to what are the impacts on the human element, and that topic hasn't been fully addressed yet, and we plan to engage the full tribal community results of this climate change project so that other aspects of climate change planning can be implemented.
The next is mostly a comment. Thank you so much for an awesome presentation. Can your slideshow be used? And I'll answer yes. We will be posting the presentation on ITEP's Climate Change Webinars webpage. And the person was interested in the use of log jams. How can students get involved, and can we call you?
I'd love to have student involvement. Again, we'd like to share this information, but also get input from students, because oftentimes people that are getting started in their career, who are in school, can have a very unique perspective, and provide recommended solutions that we hadn't thought of. So we look forward to engaging students.
Okay, great. I think we got all or most of the questions, and we are at the end of our webinar time. I just want to remind people that we will be posting the webinar and webinar recording on our webpage, probably be up there within a week or two. Our next webinar is January 30th, and it will feature 2 presentations of projects that were funded by the North Pacific Landscape Conservation Cooperative. So if you haven't registered for that one, please do so. And Oliver, thanks again. This was really great, and we appreciate you taking the time to share information about what you've been working on at Nooksack.
Well, thank you very much for this opportunity. Really enjoyed giving this information.
Okay. Well, for now, bye-bye.